Great, great. Okay. Awesome. All right, well, let's wait for more people to join. Yeah, I hope you got a chance to look at my announcement. I think we shouldn't get carried away doing new things, new games, and things like that. I know Isidore certainly got carried away, and he's doing some cool stuff. But I shouldn't be doing this. You guys should be getting carried away. So yeah, okay. So I'm not going to do that game. You guys can take that and turn that into a game. But I think we did the animation. Yes, we did the animation of the list, show animated list. Yeah, so you can take that. You can take that. You now have you know how to do micro sleep. You need know how to do sleep, and so on and so forth. Work it into a game of your own. I think that'll be a lot more exciting. Okay, so I'm going to leave it in your hands. Today, what we'll do is I want to make sure that every single one of you, right? Every single one of you is comfortable enough, at least facing the final. And so we need to make sure that if any of you are unsure about any concept, any topic, right, starting from day one, even if it's data representation, that's fine. You can say, why don't we do something in that area? Okay, what that means is that we can just that you and I will just pick a topic and a small, 5 minute program, maybe, right? That will give you more practice on that concept. For example, if you say that I want to get more practice in input and output, especially, using iString stream, right? iString stream to convert from a string to a number. Yeah, how do you convert from a string to a number in C++? Yeah, it's not like in Java or some other languages you can say integer.parseInt, and there's all these methods. Yeah, JavaScript. In C++, how do you do it? If you have a string that has 147.5, right, and it's within double quotes, how do you get the number from it? Do you have a toString method, or do you have a what is that other thing? Parse integer method in C++? Native, right? In the library, in the standard library? No, right? I shouldn't be waiting for an answer because, yeah. All right. So yeah, there is no parseInt, but you can and do one yourself very easily. Okay. So I can give you practice on that too. That's all the way back to week 4, week 5. That's okay. And if you're unsure how to do that, it's only going to take 5 minutes. Just, pick up a screen. No need to even share your URL and things like that. Pick up a screen, say write a program. Let's write a program, and we'll get a string from the user, and then we'll extract a number from the string and print it out. Okay, +1 to make sure I know it's a number. Yeah, we can do that. But it doesn't have to be that. You can whatever you want to code. If you want to code loops, that's fine. If you want to code ternary statements, that's fine. All right, play around with conditions. Okay, De Morgan's laws. That's fine. Classes, objects, yeah, and pointers too. Yeah, if you want to do something with pointers, you want to be, in fact, if you want, we can go to the class, the code that we wrote last class, which I believe has the animation of the loop, the link, the list. I think we got that. You can take a look at that, and if you have any questions at all, you can dive into any part of the code and say, hey, can someone explain this, or I can explain this. Okay, in fact, it'll work better if you just ask me, and rather than saying, hey, can someone explain this, and then there's this deafening silence, nobody answers, and so I'm just out here, and so, but if I'm here, what you can do is you can ask me, and then I can ask, right? Hey, does someone want to volunteer? I think that might be better. Yeah, because if nobody does, then I can, without wasting time, dive into an explanation. How is that? Yeah. In fact, you know what I realized? You can all switch on your cameras, because I think that the thanks Angelos. Yeah, because I think the recording on Zoom is active speaker anyway, and I think I'm, and in fact, what'll happen is that, I'll look at the recording, and if you guys are all, in it, I won't publish it, okay? But we'll take a chance. But because what I saw last time was that there was no rectangles at all, even though you were all present as rectangles without images, but in the recording there was nothing like that. So I posted it, you can see it. So I think that even though you may have your cameras on, it's probably going to record just me, I think. Yeah. Okay. Hey, Ria, Ben, Roger, Liam, Caesar, Spencer, you guys should also all switch on your cameras. Okay. Yeah. And yeah, we'll see how it goes. Okay. And I think that it'll be okay, even if you have your cameras on, because I think that way the class will be more energizing, but at the same time we'll be able to make a recording that we can share for the few people who are not able to make it, and I think it'll be better for them. Okay, great. Thank you, Caesar, Ben. Yeah, it's finals week for lots of people. I know for sure. I think it's Ben is no, actually Ben. Hey, it's funny, isn't it? UCSB is the UCs are actually one fewer week than us. At Foothill, we have 12 weeks. Yes, I think, but
We
the
just
UC
have 10
system is
weeks
only
here at the
11
quarter
weeks.
system.
Hey, Ben, UC is only 11 weeks. Yes.
The UCs are on the quarter system, so we're actually 10 weeks and then a week of finals.
Oh yeah, we're on a quarter system too, but we have 12 weeks. It's 12 weeks, including the finals. So it's 11 plus a final. But you're saying 10 plus a final week.
Yes,
for
we're 10
UCs.
plus a final week.
So that means that you must have started 1 week later than we did, because you're ending at the same time we are.
Finals week is next week, right?
Yeah, next week is week 12 for us.
Yeah, that's week like 11 for us. So yeah, we started a week later than you guys did.
Yeah. Actually, it would have been better if it was, loaded the other way, because then you can be done with those finals and you can focus on these finals. Yeah.
Yeah, it would have been nice, but luckily it's only one additional final, so it's not the end of the world, but it would have been cool for sure.
Hey, you know what? Before we start, talking about class related stuff, a couple of things, especially since, we only have one more class Thursday, and you have to let me know, right? Unless you guys want to meet in person, we'll just do it on Zoom. I'm happy with either. Okay. So, but if you want to meet in person, you have to let me know before, because then I have to plan for it too, and then I'll be there. But that's okay if we do it on Zoom. Well, two things, right? First of all, next week is basically just going to be, some, questions you may have about the final and so on and so forth, but mostly reflections. For you, while you're talking, you're going to be browsing your own profiles on Reddit and looking at posts you made 10 weeks ago and now, and then jogging your memory. And then talking about people, these things, hey, Angelos, I helped you with this very, very long time ago, right? Kira could say, hey, I saw, with the Hello World project, something like that, right? Maybe there's an interesting nugget there that you could develop on right? So you may take notes there and say, because otherwise I can tell you for sure that, by the time it's time for the finals, you're basically just going to take a dump of all the links you have on Reddit. I'm going to say, this is all the stuff that I did on Reddit. And, that's no good for a final report. So what you really need to do is showcase what you've done and what you've learned, because that is really what is important for a co-founder of a company later on with you. Right? To say, this guy is not, a person is not coming in with a fixed mindset saying they already know what to do and they just want to make money out of it. No, right? So no, a really interesting job is, you could have an exciting time learning new stuff also. And so I think that's the way to do it. Okay. Yeah. All right. So make notes. Oh yeah. All right. So the other thing that I wanted to say, so yeah, make notes and then create a good final report. And hopefully the final report should be out there, and call it reflections. Okay. Your final report should be called reflections. All right. Don't call it final report or participation log and boring shit like that. Okay. Call, reflections of CS2A. If you're planning to do my CS2B, you should enroll in CS2B. Okay. Because I think I may not take ad codes this time. But if you've done all quests, all 9 quests, you should certainly go on and do all of you guys, right? Anytime you come to CS2B, I will give you an ad code. Okay, not general run-of-the-mill students, unless they've actually done all the 2A work there. Even if you pass CS2A, having done like 7 quests, after you enroll in CS2B, you're going to have to not just do the green quest, you got to complete the remaining blue quests too. So whatever you do in blue is going to get you credit in green. So just by completing all the blue quests, you're already starting CS2B with, I think, 15 points or something like that out of 100. I don't know, so some arithmetic there, but you get a significant number of points for doing. All right, so if you want to enroll in CS2B, you should go ahead and do it. No, but that's not what I wanted to go and say. There are opportunities for internships. Okay, now there's 2 kinds of internships. They reached out to me by email today and say, can I nominate them? Right, if you have completed 9 quests in blue, right, and dogged blue, right, if you've dogged blue, you can apply to be what Chris is doing this quarter. Okay, it was basically hanging around at the Mountaineer Library, right? But no. Hey, Chris, is that a tree behind you? Are you outdoors? Oh, I see. All right, okay. Is this a Mountaineer Library?
Yeah.
All right, okay. All right. So, but anyway, next quarter, I think there'll be a lot more exciting work than we inflicted on Chris this time. So I won't be talking as much. Next quarter, I'm planning to experiment with a new style, which will be more, reflective. We'll have weekly reflections and projects we'll do together. Exciting stuff that we can actually do and reflect weekly on. I think it'll be more fun. Right, given that I'm only planning to teach for a few more quarters, might as well try all these different ways now, and so we can have find interesting ways of learning this stuff. Okay, all right. Hey, Rebecca, you got a question? You raise your hand. Yeah.
Yeah, for next quarter, will it be kind of the same layout of the class? I see it says asynchronous, like on the
Yeah, in fact, I think we'll
Zooms.
just do exactly the same. Thank you, Rebecca. Yeah, it is asynchronous and it's going to be Zoom and CS2A asynchronous 6 p.m. right? In fact, it is 6 p.m. It's listed. I think they listed it at 6 p.m. So this is kind of cool. So Tuesdays and Thursdays at 6 p.m. just like now, and it's on Zoom. You don't have to be physically present, and so you can apply to be a tutor, an embedded tutor like Chris. But we'll have more opportunities to work with students, and you won't have to be bored out of your wits, like sorry, Chris. Okay, I meant to give you a lot more work this time, but yeah. All right. But anyway, I'm pretty sure the students that did interact with you, they were very grateful, and they've made a lot of progress. So I'm very happy. And even now, it's not too late. If you need help with something, you can just reach out to Chris. You can reach out to me too, right? But he's also a student like you, so you may feel more comfortable. So you can reach out to him either on Reddit or on email and say, hey, Chris, can you help me understand this? I'm pretty sure you're okay with this. Yeah, Chris? Yeah, you can just hop on a Zoom with you too if you want. And he's like a personal tutor available 24 hours. Well, actually, let's not say 24 hours. You can email him and he'll say, yeah, okay, hop on a Zoom. Right? Think about it, because I know, I know people. Where was it? Yeah. All right. So I think it was at Palo Alto Library or Los Altos, one of those libraries, and there are these tutors, and apparently they work for this company called Wisant. Okay, and they're just teaching computer science to people. For I think $90 to $100 an hour. Okay, and these are students just come to them with AP computer science problems, maybe, who knows, right? Just picking up problems and saying, asking, I want to do this, and they tutor. And it's available. You just go there, and Wyzen gets a cut, and they get free tutoring. So this people that and they do it in public locations like libraries and where you get study rooms, like Food Library. So you got a free one. You don't even have to pay $100 an hour. So you can just email. By the way, you can also go to the STEM Center, but there's more competition in the STEM Center, yeah, because there's lots more people. And then Chris is like tailored for CS2A. So yeah, and same deal with me, right? So you can also email me and say, hey, can we hop on a Zoom call, right? Except if it's with me, even with Chris, I would highly recommend recorded. Even I don't know, all right, I don't know how it's gonna work. Well, with me anyway, we'll figure something out, and then I'll tell Chris what to do if that happens. But we've got to make sure that no other face is shown than mine in the final recording. Yeah. Or if it's just one person, they can just email me saying I consent to my face being shown on this video, and then we can put it on. All right. Okay. All right. So that's it. So we got a couple of that's one, and there's another kind of scholarship, internship, not internship. What is it? Another kind of tutoring. Tutoring. It is called an EOPS tutor. And I think you work one-on-one as a peer with an EOPS requiring student or something like that. Okay. Now the catch is the total number of hours you can work is not supposed to be more than 19 or something. Okay. And Constantine or one of these people will have more details, but I think you get paid close to $20 an hour, and you're not allowed to charge more than 20 hours per week. And and if you're in a class, this 2 hours of class counts as 2 hours right there. Okay. So even though you may not be actively coding and saying, hey, okay. So there's all these perks that go along with being a tutor, but at the same time, being a tutor is more valuable to you because you'll actually get a very good experience of what kinds of problems people run into that you didn't run into. Right? Many times we just get lucky in life, and then we just say, hey, you know what? I didn't have any problems getting here. But that we just overlook all the luck we had, because things could have gone wrong. When you're much older and you look back and you say, how in the craziest of the worlds did I possibly survive these kinds of things multiple times, right? So it's like the lottery, and so we don't reflect like that. But if you've gone to the other side, once you've figured out how to solve all the problems one way, that's what I mean. You can actually help. I think this is my theory. Okay, help by stopping there, not marching forward. Okay, all the way to Andromeda, right? And then saying, all right, now I'm going to stop here, and then put my hand out to help other people get here. Okay. Now I think it's not compassion or getting people out there. It's also beneficial to yourself, I think, because it gives you a much better understanding of where you are, because there are other problems that you didn't encounter, but those guys have. And so you get a very different perspective of this thing. And once you've helped enough people over, you actually get to a much better appreciation of the whole concept or the algorithm or whatever it is. And so you'll get a great opportunity to do that. So volunteer everywhere, not just here. After this, you're going to maybe go to college. And obviously in college, in universities, there's so many opportunities for students to make money, right? Tutoring, lab assistant, research, so many of these things. My recommendation is always to, always go for something where it is required for you to teach someone what you already know. Because even though you're teaching someone what you already know, which is really cool, because you can be confident about it, because if they're lost, you can always pull them over. Okay, this is the ground truth, and that's for sure that's going to work. You can pull them, so you're confident. But at the same time, you're also open to, well, I got here, but why is that person not getting here? Okay, so that is something that I could have run into. I didn't run into that. Okay, so you actually feel grateful too. And you say, super duper grateful for where I am right now, because I didn't run into all those problems which I could have run into. And you don't develop that until you've tutored other people to get to where you are. And so yeah, volunteer for that all the time. Here also, I'm going to try and ask for more tutors. Okay, CS2B maybe, because I'm also offering CS2C next quarter. Maybe the last time maybe I'll offer one more time CS2C. But 2B will, I think I can take a tutor for sure. Maybe Chris can do my 2C tutoring if he's still going to be at Foothill. Someone who's already finished CS2B needs to tutor in my CS2B, I think. But I haven't requested it so far. Not that we have a need for a tutor in 2B, but it is kind of, if I look at the Reddit, there's so much action and excitement in the blue subreddit. All you guys are so energetic and new ideas, and Isidore's posting these interesting projects and discussions. 2B, relatively, there's less action this quarter. I don't know why. Last in summer there was very heated, and even the previous one was spring also. Lots of students were active, but now 2B is not as active. Well, let's hope next time it'll be better. All right, and with a tutor maybe, who's on their back all the time with interesting problems. Yeah, I think what we'll do is also in 2B, if possible, certainly in 2A, we will try and come up with these kinds of interesting problems, and like the things that branched into extra credit, like Isidore and Ben and all these other people are doing, and basically say, these are the things, and people actually work towards these things and reflect on all the things that they've learned, which is part of a list that we'll circulate, right? Same thing in 2A too. So we'll try something new next quarter. Okay, so I think hoping that it will again be non-traditional. Okay, but it'll be rigorous, just like right. Okay, so anyway, that's all I had to say. Anybody have any question whatsoever, any question about any of these things that we have talked about, any concept, up to linked lists and nodes? Yeah, do that. If you want to do a project, a small project, like 10-minute project, just a 10-minute project means no animation, no fancy stuff. Okay, it has to be something like create a program, create a linked list of 500 nodes. Okay, in under 40 lines. Okay, and 5 minutes or 10 minutes. And how about this? That is really cool. Okay, how about everybody 5 minutes? Okay, only 5 minutes, and everybody has to do this. Everybody, starting from Juliana, you already got your hands up and all. Okay, so everybody has to do this 5 minutes practice. And if you don't do it, the next person it takes over. And then after they're done, you can get back in, right? So in other words, we always keep going, and everybody will get a chance. Only 5 minutes max. Okay, we'll set a timer or something. You got to create a program. Okay, you got to do a node, brand new, right? First of all, when you start the screen, share the screen, go to online GDB, delete everything. Okay, and then you're going to create a node class, and then you're going to create a main in which you're going to create a chain of 500 linked nodes, with the last node pointing to the first node. That's all. Okay, usually the last node would point to null, right? The last node pointing to the first node. That's all right. Okay, maybe that's 10 minutes. Okay, just create a chain of 50 nodes. Okay, if they get n nodes, right? 50 n nodes. Okay, and when you're done, that's it. Done. Okay, next person, and so on and so forth. And as we work through it, we'll know if we need to get it, start building on it and make it more interesting, more complicated, not complicated, more sophisticated, and so on. Okay, and we'll see where we get to from there. So that is my plan. Hey, Juliana, you have a different question, or are you gonna?
Yeah, it was actually about the final. I'm not sure if you talked about it before I got here. My question is just, is it going to be like the same format as the midterm?
Yes. It's going to be the same format. Okay. And in fact, yeah, everything, classes, objects. Did you have classes in the midterm? No, classes and objects not in the midterm. Okay, everything from classes and objects until nodes, pointers, static variables, all of those things. But you also need to know the stuff that we covered in the first 6 weeks. It's like 20%, and there 80% of it will be the new stuff. Yeah. Yeah, I think it'll be quite easy. I don't think it's just have to be careful about the questions, just like real programs, because you've got to let your mind be the compiler. And most of the time you're reading programs in human mode, which means human language, there's a lot of redundancy, and we fill in stuff that is all absent many times, crazily. But many times when we look at a picture, we don't see the whole thing. We just see some details, and the rest of it is just basically, interpolated in our brain. And so the whole picture, only when you really focus on it, we can get the detail. Otherwise, we just that's how it works. I don't know how we got started talking about that. Well, I don't know. I don't know why we started talking about that. But yeah. Oh, the final exam. Yeah. I don't know. I think we're good, right? Final exam. No further questions on the final. Yeah. All right. Okay. Anything else? Hey, Isidore, are those pipes over your head? Or is that the fluorescent lighting? Oh, I can't hear you. Oh, don't worry. Okay. Anyway, is unless anybody else has some other idea. Oh, they are lamps. Okay, they are lamps. If you don't have another idea, we can just start with Juliana. And the goal is to open GDB, online GDB, and then delete everything, and then write a program that is. I'm not going to interfere at all. Okay. If you have any questions, you can ask me. Or if you want me to guide you through, that's okay too. But the next person.
I'd rather you guide me. I'd rather have some guidance.
All right, so yeah, no worries. You have two choices, okay? Either you can code with the guidance, or someone else can. You can go next. Meaning, on my screen, I'm next. But Jink, you are after Juliana on my screen. Yeah, okay. So if Jink wants to go, they can go. And after Jink, you can say, you can jump in anytime. You still have a choice. You can say, I want to do it without guidance, or or you can do it with guidance. Oh, all right, that's okay. Too complex.
So
right. Oh, share the screen, Juliana. Right, we'll just do it with my guidance. Sorry, Rajiv. You had a question. Raj, did you have a question?
no, I didn't.
Or Jink? Yeah, Jink, you did have a question. I heard someone else.
So it's
Okay.
not my turn to show my screen.
No. Juliana's coding right now. All right.
Okay.
So yeah, you're going to be next, and you're going to start just like this, okay, with a blank slate, and pretty much the same kind of code.
Okay.
Right. So yeah, hey Juliana. So what we want to do is create a node class which has an integer payload and a pointer to another node, and you want a main in which you can create a list. Right. Don't bother about methods and classes and so on. It's just to get an intuition of the list here. And in your main, you're going to create a chain of 50 nodes, right? Each with a different random number. Is that enough? Yeah, like 10 minutes, okay? So shall we try a timer? 10 minutes, and if we don't finish it in 10 minutes, yeah, too bad for us. And we'll increase the timer for the next person. Yeah, is it okay? All right, okay. Hey Google, start a timer for 10 minutes.
All right, 10 minutes
All right, okay.
now.
All right, okay. So what do we want to do? Let's put a comment saying Juliana's code today's date, right? We want a node class. And in our main we're going to create. Hey Jink, this is what we're trying to do, and then if we don't manage to complete it, you're going to start from scratch, but you're going to take it to the next level. Basically, get closer to completion. Is that okay with you? After the timer goes off, you're going to take over and code. Yeah, is that okay, Jink?
Maybe. Maybe it's okay for
No, you can try. If it doesn't work, that's okay. And we'll just pass on to the next person and keep going like that, 10 minutes each. Is that okay?
I think okay.
Yeah.
Yeah.
Well, it's okay. I tell you, it's okay, because it doesn't matter even if you don't do it. We'll just, do as much as possible and then pass on. It's just like a relay and 10 minutes each person. Yeah. All right. So we want a node class and can make a capital N, right? and then but put a period after the class, not the period, right? And then in the main, in main, in the main, we are trying to create a chain. In main, we're going to train chain of. Go to the next line. Yeah, go to the next line. Of I don't know, 10 nodes, right? 10 nodes. 10 nodes. All right, that's all. We're not even going to print it out. That's what we want to. That's a target we set to for ourselves in the 10 minutes that we've got. Does that look like a reasonable thing for us to shoot for? Yes or no? Just thumbs up, everybody. If, yeah. Because everybody should be totally comfortable with this. Yeah, thank you guys. Okay, everybody should be totally comfortable with, here's a node, because when there's a class and there's a list and there's a node, people always think there's too much to it because of all the buildup around a linked list, saying, oh, linked list class and all these methods and so on and so forth. But the core, the soul of the linked list is lost in all of that, with all the frills around it, and say, oh, the linked list has all these methods and all these fancy things. But where's the soul of the linked list? It is just in that thing, that node which has a pointer to another node, and it's just a straight line. That is it. So that's what we want to boil it down to, and not get lost in the superficial detail that doesn't matter, and say this is what we want to get comfortable with. Because once we get comfortable with this, then you can slap on everything that you want on top of it, because you've got the core in your hands. Does it make sense? Because I know a lot of people who work with linked lists and do these things with all the features that are around that in other languages maybe, but they still don't have an intuition of what the linked list is, and the power of the linked list, where it should be used, or rather where it should not be used, right? They'll throw it into use in places where they should not. It's because they don't understand the linked list. Although they've used linked lists in so many different situations, they know how to fit these things together. But I think that is my personal opinion is that is the wrong way to look at linked lists. You should look at it from what is it that is a linked list first. It is basically a linked structure. That is the core of the linked structure. Throw away everything else that doesn't matter, right? So if you're going for the truth, you want to take everything that doesn't look like the truth and throw it away, so that you can whittle it down, all right, and say, all right, that is it. Okay, I don't have any interference there, and that is the exact thing that I'm looking for. And so for a linked list, that's what you're going for. And so even in an interview and things like that, when people say these methods you should be familiar with, no, methods are things that you can always look it up. You can ask ChatGPT or Google, or say, hey, how do I use a linked list in this particular language that comes up tomorrow? And say, hey, in this language is the API for a linked list, right? That's my 10 minutes is gone already. Okay, all right, class, hash include IOStream, using namespace standard. Thank you, Juliana. All right, you can just type fast. I think it's okay. Most people are comfortable at this stage. If you're not, you should just pipe up and let us know, right? Hash include IOStream, using namespace standard. Yeah, all right. And then one more blank line, and then say class space node with a capital N, and then curly brace, and then close the curly brace. Space there, and close the curly brace. And then semicolon after the end. Semicolon after the end. No, there's a space. Yeah, all right. Now go in between the two, and we'll just keep everything public. Okay, just put the word public right in front, right on line 9. On line 9. Yeah, right, public. So we'll just keep everything public. It's just like a struct. A struct is basically a class in which everything is public. So that's what we're doing here, is a class where everything is public. And we're doing this because we don't want to bother with getters and setters. Because getters and setters, yeah, okay, there are niceties, syntactic sugar that we add on to the basic functionality. The linked list is our basic functionality, and we add on everything, even getters and setters, they're added on. That's not part of the list, right? So if you go to the assembler code, you just see that thing there, with an address and yeah, so that's what we're going for here. So we're just going to say everything is public here, no getters and setters, which is a structure, and a structure is a bag, a class, right, to hold things together. That's all we're going to. So put a colon after the public word. I think there's only 3 or 4 minutes left. I'm sorry, but colon after that. Enter, and then tab in and say int data. Say semicolon, and then enter. and then a node space star next. Now, I'm just saying this fast because we've done this a few times. Now, if this is confusing to anyone, including Juliana, you basically pause. And so there is no mandate that says we have to get through this program in 10 minutes, right? We should just pause and say, I don't understand this. Can we just pause here and explain this more? Fine, right? Even if we've done it like a million times before, I don't care, because I'm just going to explain it in a, try and explain it in a different way. So it's fun for me too. So you should just let me know. If any of this is unclear to anyone, you should all be perfectly comfortable with, just spitting out a linked list anytime you want, the core of the linked list. Yeah. Because once you have that, then you can run all the kinds of algorithms and the powerful things that you can use linked list for. Right. So enter, we'll do all the constructor also. So we'll do the constructor and say node, N-O-D-E, node, open parentheses, and then say int D, right? Int D, and then after the closing parentheses, say colon, written a colon, and then space, and then say data, open parentheses, D, close parentheses, comma, next, comma, next, comma, right? Comma space, yeah. Next, open parentheses, null pointer, null PTR, yeah, and then semicolon. All right. So and that's it, right? So those are the only things that we need for this node class. And now we can actually do our main. Essentially, we can do our main right now. So get rid of the line 13 and and let's do our main right there. I think this is it, right? In our main, and then we can add other methods as we need when we do our main. So int main, and then open close, and then return 0 at the end, so we can flesh in the inside. Yeah, and then right, curly brace, don't forget that. Okay, yeah, right, and then return should also be indented in return. All right, okay. So now there, what we can do is a node star p equals node star p, and then node space star p is much better, because node star is not a type. Because if you have a Q after that, it's not a of type node star, right? The Q will still be of type node. So yeah, node star p equals new node, new space, uppercase N-O-D-E, uppercase, node, and open parentheses, and then in there you just say rand %1000, right? Rand rand open close, rand open close, space 1000, %1000, and then semicolon at the end, and then immediately after entering int main on the next line, just call srand also, so that our rands will always be new, right? srand, one word, srand, yeah, right? srand, open parentheses, and in there you're going to say unsigned within parentheses of its own, right? Unsigned within parentheses of its own. So you need to have unsigned in of its own. Unsigned is of its own parentheses. Yeah, there you go. Yeah, right. After unsigned, you're going to say after unsigned, you're going to say time, and then inside of time, you're going to say null pointer. Okay, time open parentheses null pointer, right? And then put a semicolon at the end, at the very end, and then space after that, a blank line after that. Okay. All right. So now a node P is given. Now what we want is after a node, after 18 is maybe when the timer will go off, right? After 18, hit enter. Yeah, one more time. All right, go up. Right. Now you're going to do a for loop, right? Say, let's say for size t, I equals, or even I equals 0, I less than 10, I plus. Yeah. All right. So now 10 nodes, right? So what we want to do is for each of those 10 nodes, what we want to do is yeah. All right. Okay, good. Hey, Google, stop the timer. Hey, Google, stop the timer. All right, thanks. That was funny. All right, so here it is, right? So everybody comfortable with this? Because the next person, Jink, is going to take over, not this code. And in fact, this code is gone, right? So it's not shared even. So Juliana is just going to delete the whole thing. Jink is going to pick up this code, and he's going to code in the next 10 minutes. Hopefully this will be faster, because I'm not going to be blabbering in between now, right? So Jink is going to code essentially this, get to this place, and hopefully this time we'll have time to do this part, the for loop. And in the for loop, you're going to make that chain of 10 nodes, right? Each time you're going to create a new node and put it in the list, right? In fact, what we can do is create a new node and put it in the front of the list. Meaning, now this is what you have to have practice in, and it's going to be fun because everybody's going to get a chance to do it. You're going to create, here's your list, and you're going to create a new node in the for loop, and you're going to take that thing here, and then the new nodes next is going to go to this guy, yeah, the second guy. And then this guy's next is going to point to the new node. So that guy is going to get slotted in. So every time a new node comes in, it is just slotted into the front, and the rest of them are just pushed out. Now, this is exactly the same as the insert operation that you do in Quest 9 and any kind of linked list. Even later on when you do dealing with trees that have this kind of thing, this is exactly what happened. And in fact, this is a saving grace of linked lists, okay? This is the only possible reason anyone in their sane mind can ever think that using a linked list is better than a vector, okay? That it says, all right, I want to insert something here. I don't have to shift anything, and I can just do this and magically get the, rework the beats, and I get this linked list, okay? Yeah, okay. So that is an advantage of linked list, but you'll find out that in our class, we're just using vector for everything. But linked lists are good to get the practice of, dealing with pointers, because you'll be dealing with pointers in other contexts too. But linked lists get you, that practice in slow running speed, right? Not super speed, like in later algorithms. Yeah, but other than that, you have to do this. You have to be able to take a node and then a linked list, and then taking that and inserting it in front. Okay, so that is a trick. Maybe I'll talk you through this. Or maybe it'll just trickle down to the next person, right? Now who's after Jink? All right, Caden, right? And in fact, you should just be 5 minutes from now on, okay? Not 10 minutes anymore, because I'm not going to be talking at all, unless you need me to. And even if I have to speak through the code, I'll just speak through the code, and it's not a big deal. Okay, hey Jink, 5 minutes, is that okay? 5 minutes. Thank you, Juliana. Well, was that helpful at all? All right, so we didn't get a lot of time to belabor any of these points, but it's just practice, I think, right? Once you do this a few times, especially if you're a programmer in a different language, you have to be super careful to just keep trying this, so you get an intuition of how these things are done in C++. Slightly different from how these things are done in other languages. All right, so hey, Jink, you just delete everything, right? Delete everything and start from scratch. Then Control A and delete. Control A, delete everything. All right, start from scratch. Hey, Alexa, start a timer for 5 minutes. All right, so it's 5 minutes
5
now.
minutes, starting now.
Yeah, 5 minutes, okay, not 10. All right, so start, go ahead. I'm not going to talk about anything at all now. I'm just going to watch, maybe, right? Maybe even look away from the screen. But if you want me to say something, just pipe up and I'll just say, right? If you want me to guide you through the code, that's fine too. I'll guide you through the code. But hopefully after we do this a few times, maybe for the fourth or fifth person should just be able to say, all right, okay, I know how this, how this cookie crumbles, okay? Just be able to spit it out in their sleep. Okay, so I'll walk you through the first few times. But later on, by the time it gets to Brian, maybe, right? You should just be able to say, all right, I'm just going to write this with my eyes closed, okay? All right, so let's yeah, Jink, go ahead, right? Tell me if you want me to walk you through the code.
What should I do?
5 minutes
Oh.
here, time is running. So yeah, here's what we want to do. We want to create exactly the code that Juliana had, which is to create a node class with an integer and a node pointer to the next. And in our main, we just need to create a for loop, which will create a linked list of 10 nodes. That's all, okay? So you'll be exercising a bunch of skills here. You'll be exercising classes, pointers, linked lists, loops. Yeah, all of these things. And it's a good combination of skills because they usually go together. And so try and play with these in different contexts, right? Even if you're doing a game, some other language, try and do these things together and say, all right, these things in a mix, right? They come and go, different parts of the solution, and just see where they each makes its entrance. Those are Shakespeare's, right? Yeah, everyone makes its entrance and its exit, right? Like that. you should let me know. All right. In fact, well, as you type, even say something. Okay. Right. So rather than it be silent, just say something as you talk. Maybe even call out the code. Call out the code so that there's some noise on the air. All right, nobody's talking, and people can also call out the code. Okay, that's fine.
Node should have some value. So like, what type is it, Professor? What data type should the node hold?
Int data, and I think a node star next. Yeah.
It's not a huge deal, but probably just make a next instead. It's easier to follow.
You can make a parameter just D, int D.
So even if you're not able to do this in 5 minutes here, you should take this as a good measurement or a milestone for your exams or other stuff. Is you should be able to do this in 5 minutes eventually, meaning that you should practice until you're able to do this in 5 minutes, at a random time, right? So essentially, we're just looking for some task that we can help to calibrate our own coding speed, right? Or to tell us where we are in a particular language. So you can say that you should be able to do this in 5 minutes or less. And if it's taking you longer, that's fine. That means you are still in the early stages of this language, which is fine. Okay, CS2A. But what that means is that even though it's taking you longer, you have to be aware that it's possible to do that in under 5 minutes. Even if you're just woken up in the middle of the night, right? Yeah. Alexa, stop the timer. Thanks. All right. So yeah, even if you're stopped at in the middle of the night, you should just be able to just knock it out. Okay. And until you get there, keep practicing. It's not just for CS2A or these things, right? So I also mentioned this in other classes. It's important to be really competent in what you're doing. Okay. So whatever it is, you got to be good at what you're doing. Yeah. And so that is why it is really, really important to get to the bottom of these things. It is not for your grade at all, because it's like going to med school or any of these things. This is a profession, right? Computer science is a profession. And it's today in computer science, you can train for two different kinds of things. One is for the more maintenance kind of job, okay, where it's just ordinary stuff. You don't get to do exciting stuff. But if you really know computer science, you can do the exciting stuff in computer science, which is you work at the frontier. But you don't get to do that unless you're really, really good. It's like saying, I can't. You have to know how to use all these fine tools. Otherwise, you say, I only have an axe, but I want to perform a surgery. No, do you know how to use a scalpel? Or something like that. You got to. So these are the tools of the trade. And if you really are good, just by practice, because it doesn't come by, I got to read all about it and I understand how it works. Yeah, okay. That's not the way it works. You got to do it because you actually just feel it and say, this is the way to do it. And then you'll be good at it. And then, so nobody can tell you, that that's the wrong way, to do, or, there's a better way to do it, or the way that you should do it, if it is not as good as what you've got, because you actually have a proof, right? As you can actually say, this is the right way to do these things. All right. So anyway, even though we're going to go on to the next person, Jink, thank you very much. Okay. But however, we didn't get to the place where we got to the for loop. Okay. Now that's because you're only the second person in the right now. Ben is probably going to get, and he's also got some more practice with programming too. Right. So he may get to some, stage. And after Ben, I think on my screen, I have Raj and then Rebecca. So everybody will get to a different level of this program from the beginning to the end of the return zero with a for loop and everything fleshed out. And by the time I think we get to Liam or Ria, hopefully this would be done so many times, okay, that as long as you're following what's happening, you'll just be able to just read it out. By the time it's your turn, you say, all right, main instant, bam, 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 bam. Okay. And because you know how these things work. Is that okay? All right. So the next person to take the screen would be Ben. And everybody knows what we're shooting for. Yes, what we're shooting for is essentially a program in which you're going to create a node class of a very simple structure, and then in your main you're going to srand, and then you're going to create nodes and make a for loop, and in that for loop you're going to create a node, a list of that many nodes. Okay, once we have that going and then everybody's comfortable with that, we can try the next stage, which is, we've created the list, but we also want to be able to destroy the list, right? Meaning that you have to clear it. And that is also a challenge for many people, especially if you're not guaranteed that it is a list, right? Who knows? But, a list ends in a null pointer at the last node, yes? However, if it's not a list, but it's still a linear structure, the last node is not a null pointer, but it's actually the first node, meaning it's a ring. Okay, it's a ring. How do you delete the nodes in that ring? So you can't keep going forward until you hit a null pointer, right? Because you'll never get a null pointer because it's an infinite loop, isn't it? So you got to have some interesting ways in which you can delete the nodes in a linked list. Maybe we'll get to that today, right? Even tomorrow, on Thursday. Thursday is largely a reflection class. You'll get to talk about, like I said before, everything you've done so far and generate ideas for your reflection post, okay, which should be done by this Sunday, I think, right? The reflection post should be out by Sunday so that you can start thinking about the final and preparing for the final. And I think on Friday, or Saturday morning, I'll freeze all of the scores. Okay, I'll freeze all of the scores. Late points for the previous ones, but I think the quest number 9 is open until the end of this week. End of this week for sure. Right, so no late points on 9 until the end of this week. So please go ahead and complete that. Yeah, and also a list of topics that we need to study for the midterm. You can, if a final, you can share those on the forum too. So these are topics I've been studying, and people can chime in and share these resources. Also, if you find some interesting things on campus, like free cookies at the STEM Center, sometimes sometimes I've known that they buy pizza or cookies for people who are studying late or something like that, and you can make a post and say, hey, if you're hanging out in here, I don't know if people see Canvas and things like that, but you can certainly put it on Reddit. Say, hey, we're on campus, and come and grab a bite at the STEM Center, PSAC, whatever it is. Right, so interesting things like that. Final week is usually like that. I think it's interesting. Roger, you should switch on your camera too. All right. All right. So hey Ben, whenever you're ready, take the screen. We'll start the timer in 5 minutes, and then you can just knock out this program. You'll probably be done.
Sorry.
Right. You got to start from scratch. You got to start from scratch.
Start from scratch.
Yeah. All right. Okay. Alexa, start a timer for 5 minutes. Well, let's just say 3 minutes from now. Okay. 3 minutes. Alexa, stop the timer. Alexa, start a timer for 3 minutes. Alexa, start a timer for 3 minutes. So in
3
fact,
minutes, starting now.
because I'm not even going to talk. So you can just delete and go ahead. Yeah, hey, dismiss the Ben. You can dismiss the white part of the screen and then the blue part too, so that you'll get more screen, real estate.
Better.
Great. Hey, where did you get all that data from? It was already there, was it?
The class?
Yeah.
Then no, I just wrote it.
Oh, all right, okay. I thought it was there in when you started online GDB. If anybody has any questions, you can just ask, okay? So Ben is just typing fast, because of the 3-minute limit, but if you have a question, you can obviously ask. Okay, I'm just gonna drink some water. I'll be back in a sec. All right. You done?
No, not yet.
Oh, you want to print it out here?
Yeah. Do you want me to print it while I'm doing it? Like in this for
Yeah, you
loop?
can. No, not while you're doing it. So after you got the list, you can print it out. Does it actually make a list? I'm not quite sure. I can't see. I'm going to look at it and say I don't know if it's going to do the right thing. What is it doing?
Wait, for
Not
for
sure.
loop, do we
Go
have
go
to
ahead and do the print. Go ahead and do the print part, assuming that you have a list already because your timer is running, right? I'll take a look at this part.
Wait, what was the question?
Wait.
I don't know. I might have done this wrong.
for loop, do we have to have size tiers in okay?
Oh, you're adding. Alexa, stop the timer. Oh, you're adding 1,000 nodes, are you?
Yeah, was that not what we were supposed to do? Sorry.
Yeah, no, just say 10 for now, so that we're going to print it out and all, right? So it'll be, easier on the eye, right? So, all right, 10. In fact, the second for loop should not be on over for I from 0. It should be from, first node until you hit null, right? That's what it should be, isn't it? So in fact, the loop should be, yeah. Yeah, in fact, what we should do is since the timer ran out, yeah, right. Hey, Ben, you should certainly save this code and then take a snapshot of lines 16 to 20, right? And then maybe do a Reddit post or something to confirm that it actually does build the list the way you want it, right? Or you can say, well, there was a bug there and I didn't notice that in class. We didn't get a chance to dive deep into this. And for the next person, I think Raj, we're going to start from scratch again, right? And so we're going to go after what he's this part, which is to build up the list. We're going to go to another for loop, another kind of for loop in which we start from the first node. And then until it's null pointer, you're just going to keep jumping to the next, right? A slightly different format. Maybe I'll talk you through that, okay? Unless you already know, Raj, right? How to do that kind of loop. I'll talk you through that. So two major formats of for loops, generally. I think these are the two. And, one involving pointers. Very useful to know. So Raj, whenever you're ready, take the screen and then 5 minutes. And then you're just going to, delete everything, control A, delete, command A, delete. Yeah. All right. So you're going to start typing, create the class node, and then, the constructor and things like that. And then in your main, you can do the thing, right? So to add 10 nodes, each with a number. At a random
Want me to
number.
make that a comment?
No, just go ahead. Everybody knows, I think you also know what we're doing. And then, most of this, we're not sharing the code and all. It's okay. If you have any questions also, you can, tell. he can ask us, right?
Yep.
Yeah. Also indent the public in with class is better. Yeah, most of the time. Oh, I see. You're doing 3 levels here.
So you want me to, is it better just to,
Usually, yeah, that's yeah. Then you save a little bit of space horizontally.
gotcha, okay.
I actually don't know if we have a timer running. Do we have a timer running? Alexa, is there a timer? Alexa, how many minutes are left?
There are no timers set.
All right, so we never started a timer. All right, so let's say let's say 3 more minutes, okay? Alexa, start a timer for 3 minutes. All right, so 3 minutes, okay? Let's try and finish this up in 3 minutes, and then the next person that I have on my screen is Rebecca, right? Who is going to do exactly the same thing, right? Maybe a few more lines, and right.
Do I need a
And I think it's good
semicolon?
to do all these, many times. Every student does that. Yeah. Yeah,
Yeah,
that's great. Get rid of the blank line on line 13. You don't need the blank line on line 13, I think.
I'm just a little bit stuck here again. So
Yeah,
for
yeah. New node,
installing this
new
first
node,
one,
new node, and also attach the star to first node rather than to node star, so that it is clear
okay.
that first node is a pointer,
Yeah.
and then the star of the first node is really the contents of the first node, right? So the contents of the first node is of type node. That's what we're meaning, right? Lots of people get confused about what the syntax actually means. It means that node star is not a type. It just says that whatever is after the star is a pointer. And the star of the pointer is the contents of the pointer. And then this says the type of the contents of the pointer. That's a node. And that's how you read everything. So int star x, int star p, right? P is a pointer, star p is an integer. So, right, int star p. Right. So first node, all right. So well, yeah, you want to do a for loop and you want to add 10 elements, right? For size t, yeah, int I equals 0, I less than 10. Yeah, I less than 10, I plus plus. Yeah. So node star q equals new node. Node
should
space,
star
node
go
space, node
here
space,
or
node space, star q equals new node.
star Q like this? Star Q
Yeah, anything. You can call it anything. Yeah.
equals,
I'm just saying q, but you can call it anything. It's like 2 lines, right?
oh yeah, okay.
Yeah, I think Ben called it new node. So I think Ben in Ben's
Probably
code, it
better
was
to-
called new node, I think.
Okay.
Oh, you want to call it new node too? All right. All right.
So the new node
Yeah, new node equals new node, right? New node. No, new space node, new space node, and then the parameter to new node is going to be a rand function. Yeah, all right, semicolon after the end, at the end, right? And then, all right, and usually there's no space after the node, node open parentheses, that's fine, right? So you got the new node there. Now what you want to do is you want to add the new node to your first node before whatever it's pointing to. So what you want to do
So do you want to do
is
current node plus equals? Or no, it's not plus equals, it's you want to concatenate it somehow.
So what you want to do is so your first node's next node. Yeah, you want to concatenate. That is correct. All right. Yes. No, actually, no. Let me take that back. Okay. So you don't want to concatenate because all right. I don't want to use the word concatenate because concatenate says you want to put this on the end. Concatenate somewhere to me seems more like append. Yes or no?
Yeah.
All right. That's not what we want to do, right? What we want to do is we want to insert it. So in a list, if you want to put something on the end, it's always expensive because you got to hop over all of these nodes and then get to the end and insert it there. isn't it?
Mhm.
So a list inserting at the end is really problematic. Just like in a vector, inserting in the front is problematic.
Yep.
So what we want to do in a list is basically, as soon as we get a new node, we want to just insert it in the beginning,
I
push
see.
front. Yeah.
Okay.
Right. So what we want to do is first node arrow next equals new node
Arrow.
next. Arrow next. First node arrow next. Yeah, first node arrow next. Actually, it's not first node. I think it's P, isn't it? Yeah, I thought you had a P or something like. Oh, current. Oh, yeah, current node. Is that what it is? Hang on. Current node arrow. No. I think it's just first node. First node. It is. Why do you have the first two things there?
Where?
First node and. Yeah, get rid of the current node thing. We don't need the current node for now. Yeah, I think. Yeah, first node arrow next equals new node. No. The thing that you created.
Oh, I see. Like that.
No. Actually, no. So new node arrow next equals first node arrow next, and then first node arrow next equals new node. All right. So this is the part that I think is the thing that we need to wrap our minds around. So write this down, right? And maybe, hey Ben, this is what you also had. I didn't think it was what you had. That's why I thought maybe it was the structure of the list you're creating is different from what I'm proposing here, right? So what we want to do here is new node arrow next, yeah. Instead of that, yeah. No, right there. Instead of yeah, go on to the end, yeah. No, wait a sec. Go to the end of 19 and hit enter. Go to the end of 19 and hit enter. Right, new node arrow next equals first node arrow next. Yeah, and you can get rid of the space before the arrow. It's, it's like, sticking the thing to, yeah, it's like the 1 unit. Yeah, there you go. All right, next. And then first node arrow next equals new node. Now, is this what you had, Ben? Go on the next line, hit enter, Raj, right?
What I did, I think I did first, I did the same first line in the for loop, and then in the second line, I did first node next equals new node. And then I set first node equal to new node. But I also declared another node pointer, current node.
All right, whatever it is, I think it is worthy of discussion. Okay, so after we complete this, Raj and you have these two fragments, and you should say, all right, these are two ways in which the loops were lists were built, right? And you can basically discuss it, right? And say, hey, maybe there's a bug, maybe there's not a bug, and maybe the structures are different, and this puts all the nodes in the front, and this puts all the nodes in the end. Whatever it is. So there are two different ways in which you can do this. Yeah. Now, who can confirm that this will actually work? Oh, well, let's complete this by the way. Okay. You're gonna say first node arrow next equals
run of like the for loop. I don't think the first node has a next. I think next is null pointer. So I'm not sure if this will work.
That would still work. But you just need an extra line afterwards saying first node equals new node.
Let's complete this.
Okay.
Complete this. First node arrow next. First node arrow next. Equals next equals new node. Yeah, semicolon there. That's it. All right. So hey Krishav, are you here?
Yeah, I'm here.
So were you the one who said that there was an issue with the for loop here?
I didn't say there was an issue with the for loop.
Who said? Someone said there was that for loop won't work.
I thought there was an issue, but I was wrong.
I don't know. Maybe there's an issue, right? We haven't run it. Hey, until you run it, the proof is in the pudding anyway, always, right? So until you run it, you never know if there's an issue. And we're not going to run it. Okay. So maybe there's an issue. No, don't run it. Don't run it. Next person should, try it out. Eventually we'll get to run it when we get to Brian or someone like that.
Are we planning to have the so this is just going to insert it right after first node, so the first node stays the same each time?
Yes.
The beginning
Yes.
stays the same.
Yes,
Okay.
yes, and you can actually call it the header or whatever it is.
Mhm.
Node 0 maybe, right? In fact, on line 16, instead of rand, you can just say 0, new node 0. So the first node has the element 0 in it, right? And then every node that comes in is getting added immediately after the first node. So it'll push all the other ones to the right. Does that make sense?
I was just confused on like what was the purpose, like if we're gonna have the first one moved as well or keep it the same spot. So
No, the first will always be at the same spot. That is the
Okay.
easiest way to implement the linked list, right? You need to have some kind of a handle on these on the linked list. If you don't have a handle, then you have to have references to pointers, and it gets really messy soon.
Mhm.
That's why even in the quest, you always have this header
Yeah,
node.
the Sentinel one.
Yeah, I think Rebecca tried to implement it the other way, and she posted something about all the challenges of doing it without the Sentinel. And you can also try to do this without the header node, right? And things like, oh, that's what it is essentially, really, because we're using the header node as a Sentinel in our structure. All right. Anyway, so now the next step is Rebecca. So Rebecca, you can do exactly the same thing. However, if you manage to do this in 5 minutes, you can also do this other thing, which is to do a print. You're going to iterate through the list. Maybe write a function, and which is going to take a pointer to that list, and it's going to print out all the elements separated by a hyphen. Yeah. All right. Okay. And the next one is Caden. Okay, Caden, you're up next after Rebecca. Yeah. All right. Great. Alexa, start a timer for 5 minutes. Alexa, start a timer for 5 minutes.
5 minutes, starting now.
You can also talk while you're typing. It is, it's strangely enough, it is an additional mnemonic device for these things. Just like any other thing, as you're talking, you'll just get into your mind these structures. Because these are fundamental structures. Fundamental structures meaning you're going to be using them in a lot of different contexts. It's better to just commit them to memory, rather than to reason about it every single time. You just type, node star A, B, C, and so on.
Did you say that the new node, the value should be 0?
What?
Yeah, I did. 0, because you're not going to move it, right? Only the other nodes, you're just going to, that's like your head node.
Okay. Are we doing a certain number for Rand? Like between
Yeah, I think 100 should be fine because it's only 10 elements. Yeah. So as other people are following Rebecca's code, you'll get a very good sense of what you're going to type too, right? You're coming up next and you'll know. And so essentially each person typing is practice for everybody else too, which is really cool. I kind of like this because even though one person is typing, everybody's getting practice.
And then did you
You
want
can
me
do the
to
print. You can do
do,
the print. Yeah, you can do the print. You have time, I think. It hasn't. I think you have another minute. You can easily do a print. Doesn't have to be a separate function. You can just do it inline right here, right? You can do another for loop just printing everything out, and then the next person can move that into a function. You can do a while. Oh yeah, you do the other kind of for. Okay, even if the timer runs out, I'll walk you through this. Okay, all right, because this I promised before. So for node star p equals head node for node for. So this is a very useful construct, okay? Very useful idiom when you're working with linked data structures in general in C++. So for node star p equals what is it? Head node. Yeah, and then semicolon p is not equal to null pointer, and then p equals p arrow next. All right. So on the next line, you're going to say print p. Yeah, print p arrow data. No. C out. Right. I'm sorry. C out. Left shift. P arrow data. Is it data? Yeah, you call it data, right? No. And then left shift a hyphen and left shift a hyphen. After that, hyphen within quotes, within double quotes. All right, and after the for loop, at the end of the for loop, you're going to say print null ptr endl, right? At the end of the for loop, after the for loop. Yeah, since in fact you only have one line, you don't even need the braces. Yeah. See out, and then null pointer or null within quotes. Within quotes you can say null, and then endl after that. That's it. If you run it now, you should get 10 numbers, I think. Well, okay, we didn't. What? Oh yeah, this is syntax error. All right, so the next person can fix it. Okay, no, that's it. All right, that's your time is up. But it's very close, very close. Okay, so you're gonna delete all of this. So Kaden, do you see all the code? You're not gonna get much more of a view of this, right? So Kaden, you're gonna take the code now, and hey Alexa, stop the timer. Alexa, stop the timer. For Google, it has to be hey Google, and here it's not hey Alexa. All right. Okay. Kaden, so the next person up, you should just be able to do the whole thing from scratch again. Is that okay? Until the print part. Yes?
All right. Okay. Let me share my screen.
Okay, all right. Alexa, start a timer for 5 minutes.
5 minutes, starting now.
Dismiss the blue and the white part. And then also, I think your monitor is like 4K or something. You need to increase the font size. I can't read anything on the screen.
Let me finish.
You done?
Yes.
All right, so you want to run it now and let's see if it produces an output. Oh, how come you got a plus and all? If you got a plus, do you have a plus? I thought I saw some plus. Anyway, what is that? See, all right, STD lib. You got a typo. CSTD lib. No, no, you put the C back. You see CSTD lib. All right. What else? What else? I think you had one more somewhere. Yeah, where is it plus? Where is it plus? You got a plus there. Wow, how come these numbers are so big? So you didn't do a %10, like a %100? Okay, great. All right. Hey, Alexa, how much time do we have left?
You have 50 seconds left on your 5-minute timer.
Great. Okay, so we did it in 4 minutes. Yeah, that's great. So I think everybody should target doing this in 5 minutes or less. It'll only take 3 or 4 times, okay, max. And then it'll just come naturally. So the next person, Angelos, you should try to do exactly the same thing as Kaden did. Start from scratch. Try to get the whole thing down in 5 minutes or less. It's okay if it takes longer, but it just means that you need to do it on your own after this. After class, you need to do it on your own. In your mind, you got to set a timer on your phone or something like that. Say 5 minutes, and then say this is what I want to get to, right? And you need to get everything down. 4 to 5 minutes. That's the target for this. Okay. And I think this is the basics of quest number 9 and also quest 1 of green. So once you got comfortable with this, this maneuver will save you lots of time in the quest 9 debugging, because I know that a lot of people in quest 9 get stuck with, this broken pointer error and things like that. Alexa, stop the timer. I think it's because when you're dealing with the other frills that you need to add to the list, if you're really solid about the links itself, then you won't get these broken errors. You'll only get these syntax errors and things not visible and stuff like that. A lot easier to deal with. But that's why I say, so when I was thinking about it before, I thought, well, you know what, the reason students are getting stuck at the same places is because the quest, most assignments really, right? I think around linked list are structured in such a way as to weight the other aspects more than the fundamental structure of the linked list. And so I think that if we just take all that away and say, well, there's no such thing as a push front or advanced current and all these things, it's just frills that we add later on in the quest. Because all of that will just fall naturally out. Because what you are doing today, like Rebecca and Kaden, and what all of you are doing is really your insert operation. And once you know how to insert, and then also maybe the next person to do it, maybe if Angelos or Kiera or Vikram, once you get further, we can also say, all right, after inserting that many, a certain number, let's say some numbers, we'll also do a linear search through the list and say, I want to find a certain number, if it exists in the list or not, true or false. Yeah. So that we can do that. So there are lots of interesting things we can do. Hey, Angelos, whenever you're ready, you pick up the screen, yeah, and then you're going to delete, and then you're going to edit the. No, I have a feeling this, the gallery is going to get recorded. No, maybe I'll get a one person view also. If not, I won't post this. There's all the more reason for you guys to start visiting class and actually attending class. Yeah, I say that in week 11, week 10. Oh, this is week 11. This is week 11, and on Thursday, how many of you want to do it on Zoom? Right, we'll just do a rather than email and do this. Just raise your hand if you want to do it in Zoom, like now, a reflection on Zoom, or if you want to come to class, right? So let's just say, do it on Zoom. Raise your hand. Okay, Juliana, Raj, Jink. No, you want to? Are you? No, that's great. All right. So some people want to come. All right, Megan. Oh, you're online. Yeah. That you want to do it in Zoom. Yeah. So that's Spencer, you want to come to class? So it's a few. Right. So how about this? Right. Let's do it the other way then. If you actually want to come to class, raise your hand so I can get a count. Right. If this is only very few people, I don't think we'll do it, especially if it's going to rain and all. Okay. So all right, Raj, Spencer. Right. There's 2. Nobody else wants to come to class. All right, so there's two people. I will play it by ear, okay? So maybe it's all the weather and other things. But if there's only two people coming to class, I can actually come to class just for two people too, and then we can zoom from there for the others. But we'll see how it goes next class, okay? All right, so that's Thursday. That's day after tomorrow. Roger, what is your thumbs up for? Hey, Roger. All right, okay. I don't know. All right, okay. So how about who's next? Okay. For those that want to come to class. Oh, I see. Roger, thumbs up for wanting to come to class. Okay, so we got three people wanting to come to class. Okay. All right, okay. Yeah, okay. All right. All right. Who's going next after Rebecca? Angelos, did you take the screen at all? I think you haven't done yet. Yes.
I think in the chat he was saying that if it was possible to skip this part.
Okay, all right, no worries. Okay, so you jump in later too, because you have your position in line, so you can say, all right, maybe after Krishav and say, hey, I'm ready to go, right? You can jump in anytime. Is that okay? Great, okay. Vikram, you ready to go?
Sure.
All right, take the screen. You want to do everything all the way up to who was the last person? Rebecca, right? Okay, everything that Rebecca coded, also print. No, it's Caden, right? Until the, until the print out everything, and then if you manage to finish it in 4 minutes, for the last minute, what we can do is add one more. We'll add a the delete method, okay, which is going to take the list and delete the list, which is also tricky. Yeah, it's tricky. So you got to do that.
Did you start the timer?
Thank you. Alexa, start a timer for 5 minutes. Maybe I should just use my
5
phone.
minutes, starting now.
It's actually easier if I just use my phone. I gotta figure it out. Oh, it's under stopwatch, is it? Okay, it's under stopwatch. 5 minutes. No, it's 5 seconds. Actually, the interface is really poor here. All right, so I'll just continue to use Alexa. Those who want to be tutor next quarter, send me email, okay? Please send me email, because if you send me email, I will forward it on to the relevant people. So give me a thumbs up or something in your in your gallery if you get this message. If you want to be tutor, either in class like embedded like Chris is, or you want to be tutor in the STEM center for an EOPS opportunity, I think it pays the same. But in class, you get free hours as an embedded tutor too. Send me email and I will forward your name. Has to be done like in a few days, because after that they'll probably pick other people. So just give me a thumbs up or something that if you get you got the message, that if you're interested, you'll send me a message, email, and then I'll forward your name. That's for next quarter, not this quarter, next quarter. It's a very useful experience. It's actually pretty good, you know. I mean, so we get an opportunity, so many people getting a chance to code, which is really cool. I think we got through at least 4 different people coding today. Everybody should get a chance to code many times in class, I think. And I think that's somehow I'm going to try and work in more and more of this in the next quarter, to make sure that students are actually here and coding rather than, you know, me coding all the time. That's the only way to get good at computer science, I think. Just like in math, I've told you, it's, you know, we all think that we understand things, but if you do it, then you understand that understanding is not enough. We also need practice.
Did I get it?
No, you got to say PRO data on line 22. Is that it? I think. I think there was an error before. I think there's a missing semicolon somewhere. Oh, you put the semicolon after the class. Okay, you should run it now. I think it looks okay. Oh, no. No semicolon. No semicolon. You need the braces. You need the braces. Yeah, it's just syntax. Yeah, braces right there. You're not using namespace?
No, I didn't include the line for that. Let me actually just do that to make it easy.
Yeah, because you got one more C out also somewhere. And then you probably have endl and all. You're probably down to like 30 seconds left or something. Yeah, run it. Ah, geez, okay. It's pretty close. It's pretty close. Okay. All right. So you got to the end. Okay. That was a good experience, Vikram. Hey, Alexa, stop the timer. So that took 5 minutes. So see if you can do it less than 5, and then introduce more and more challenges to this, right? So the next step is going to be after this. Thank you, Vikram. Okay, thank you. I think Kira, you're next. And then Kira, what you can do is if you get to the end within 5 minutes, what you can do is implement a delete loop. Okay, so in a loop, you got to delete all of the nodes so that you got the new in the first part, getting all the nodes from the heap, and at the end you got to release all the nodes back into the heap before you exit. Okay, so I don't know if you can manage to get to that in 5 minutes, but we'll see, you know, because every person will get slightly faster than the previous one, right? So who knows, right? Maybe at the end it will be like super duper fast. All right, okay, cool. Whenever you're ready, you should just pick up the screen, and I'll start the timer when you say go.
Sorry, I was on mute. Just a second.
Yeah.
Okay, go.
All right, Alexa, start a timer for 5 minutes.
Five
Kind of fun.
minutes, starting now.
Kind of fun, like a game, and you know, a kind yeah, a game. You know, a little race. Even though it's a friendly race, nobody really cares, but it's kind of fun to have this target. And look, we're only at 7:35. We got 15 minutes more at least.
Hi, Professor. I joined a bit late. Could I code
Mhm.
afterwards? Because I haven't.
No, I think you're after Ria actually. So I was just
Oh,
following
I
the position of the photos on my screen.
Okay, I see.
Yeah. So after Kira is Zach, and then Roger, Krishav, Spencer, Megan, Ria, and then Dylan. Why is Brian ending up at the very end? Because you know, I haven't seen you in the top half of the screen before. Maybe this is no, it can be alphabetical. LP. It's not alphabetical. It's, I don't know. Maybe it's the order of joining the meeting or something like that. Hmm. Hmm. Yay. So that's really cool. Yeah, you still have time, Kira. Okay. So see
Okay.
if you can do the destructor. Delete, delete, delete. Okay, before the return. So if
Okay.
Kira doesn't manage to finish it, the next person, who's the next? Zach. Okay, Zach, you're going to be doing all of what Kira has done, plus try to cram in the delete part, meaning you're going to, delete all of the nodes. Okay. So you can work this out in your head. By the time it gets to your turn, you're going to type all of this and that plus the delete part. By the way, you know what? If there are people who are less confident and want to do it, that are down the line, you can just say, I want to go next, okay? And I'm pretty sure Zach or whoever it is, I say, all right, I'll go later. That's fine. Is that okay, Zach? Because I know you've got a bit more practice. Yeah, you got a bit more practice. Hey, Alexa, stop. Alexa, stop. Okay, so Zach, Krishav, Spencer, Ria, okay. I know you guys have more practice. Dylan, you too. Liam, I think you also have a bit of practice, but I don't know. I haven't seen Brian code recently. Okay. And then I don't know, Juliana, if you want another turn, that's fine. Okay. You want to go again. Isidore, I know you can, you're reasonably comfortable with this. Caesar, Eric. Okay. So you guys get first preference. Megan, Caesar, Eric, Brian, who else don't I remember coding? Roger. I don't remember Roger recently. Okay. Everybody else, I actually pretty much remember. In the last 4 or 5 classes, I've seen you guys code. Okay. Angelos, I haven't seen you code. Maybe I've seen you code, but if you want to take a chance anytime, right? So here are the things. Okay. So I'm going to exclude the people because we only have like 10 minutes left, really. So I'm going to exclude people that I think I've seen code in the last few classes, which means that we're going to skip Zach. And then Roger, you can go if you want to take a crack at it. Okay. No, not Krishev, not Spencer. Megan, you coded recently too. Yes, I remember. Yeah. Okay, Ria coded, I know. Dylan coded most recently. Sorry, Dylan. Okay, so maybe next class we can code something else. And we pick something, or just do an extra credit project, right? You pick this and turn it into a game. You share it like what you did before. You did an extension of some game, I think. Yes, it was really cool. I played it too. So yeah, you can do that. Liam, yeah, you've been working on Quest 9 and you're pretty, comfortable with this, I think. Yes. Okay. All right. So I haven't seen Brian code recently. Okay. So Brian, Eric, Caesar, I think. All right. And Julian on too. Juliana just coded, but she said she wanted to have another chance if possible. Okay, so Angelos and Juliana, you can jump in if you want, but otherwise, I'm looking at Roger. If not Roger, I think the relay would pass to Brian. Okay, so Roger, are you able to code? Do you want to practice? Roger? Hey, Roger's probably checked out. Maybe he's stepped out for a bathroom break or something. Okay, but Brian, do you want to code?
Yeah, I could give it a shot.
All right, so 5 minutes. So I'll start the timer as soon as you're ready. You want to do everything that was it Kira who did coded most recently? No, Kira. Yeah, yeah. So you want to do everything that Kira did, and then also try and do the delete at the end if you're able to do that in 5 minutes. What you want to do is grab onto the node and then delete the nodes, not recursively, meaning that you can't say delete that and then the child deletes it. You want to say grab onto it, all right? Pull it out, delete it. Pull it out, delete it. Pull it out, delete it. So you want to peel off the nodes and delete them one at a time, right? Until you get to the null pointer. So it's a very useful trick to know. And it's a pattern. It's a pattern. So maybe you won't get to it at the first time, but a couple of students down after you should be able to nail this. Okay. So all right, let's start a timer. Alexa, start a timer for 5 minutes. Increase the font size, Brian, right? Command plus or something like that. Well, what browser is this? Is this a Mac? Doesn't look like Safari.
Probably incognito.
Oh, is it? Huh. But where are the Mac icons? Like, close the window, expand the window, and so on. Oh, it looks like Windows. Oh, I see. It's not. Yeah. I was looking for the Mac, the circles on top and the left, but it's actually Windows on this side. All right. Okay. So lines 18 and 19 that Brian is typing is the part that most students find confusing. So that is a part that I think if you are uncomfortable with lists is to focus on because it kind of looks unintuitive, saying it's like a circular assignment. but you'll see that what's going on is basically just rearranging, shuffling the pointers, right? You're taking this and putting it there, and taking that and putting it here, right? And but it doesn't. The syntax seems to suggest that there's some circular thing going on there. And also the second form of the for loop that Brian is typing right now, line 22. It's useful to know. Iterating through a linked structure, with a for loop. This is what could be better, right? There's no branching. There's no two things to be processed at any point. So it's just hopping from one to another. So that is a very standard structure to remember. In many algorithms that you process using linked lists, this is the kind of loop that you'll be using. So the second, so for node star p equals head, and after the semicolon, you want to say p not equal to null pointer, right? P is not equal to null pointer. P is not equal to null pointer. Yeah, all right. And then finally, p equals p arrow next. And then in the body of the for loop, then you can have your, curly braces, and inside the curly braces, you can, I think we said no, didn't even need the curly brace, right? Or did we need? Yeah, we did. We needed the curly brace for making the list. And when she printed it, she didn't want a curly brace. Oh, you are printing it now, are you? Oh, I see. Okay, and then you want to do the null at the end, yeah. Yeah, the indentation is messed up for cout. Yeah, right. Are you using this one space for indent? Wow, that is very brave. Okay. Great. Okay, so you have time. To complete the deleting part. So you want to peel the items off one at a time, just like you're doing with the other for loop, right? So you can think this through too. Or if Brian is not able to, who's the next person to who's the next person after Brian? Yeah, either Eric or Roger, or Angelos, when they pick it up. You should try to do all of that. And just like that other loop where you actually construct it, all you're going to do is start with the head node, and then you're going to take the next node, pull it out, meaning you're going to take the head nodes next and point it to the next of that guy. Well, that guy is pulled out now. So that is the only other maneuver you need to be really conversant with lists. Now we've seen how to insert something. We want to also be able to say, you want to pull something out. How do you pull something out? You got a bunch of chains, right? So grab onto a node saying, all right, I want to pull out head arrow next, right? So let's say P equals head arrow next, right? And after that, when you got P equals head arrow next, you're going to say head arrow next equals head arrow next, meaning it's this guy, instead of pointing to the next guy, he's going to point to the guy after that. So skips over. Now, but this guy isn't lost. It's not a memory leak, because you got P arrow next pointing to that guy. Now you can delete this guy. Now, does that make sense? Yeah. Right. So that is the only other maneuver that you really need for quest number 9 and quest 1 of 2B. Inserting and deleting nodes are the biggest challenge, because searching is okay. It's not a big deal. You just bam, bam, bam until, right? So inserting and deleting are the biggest challenges. And so you should practice that. So we have time. Actually, we're over time. But anyway, we can continue this on Thursday, by the way. After the reflections, if we have time, we can continue this and do, anyone who hasn't had a chance can continue. Thank you, by the way. Who was the last quarter? Was it Brian? Brian. Yeah. And after you, hey, Eric, are you here?
Yeah, I am. What's up?
Oh, I see. Yeah. But you didn't get a chance to code at all today. So are you going to be here on Thursday?
In class specifically, or do you mean like physically?
Well, let's say Zoom, right? Let's say Zoom, because I think it looks like Zoom at this point. Only 3 people want to be in class. So will you be attending on Thursday?
I would assume so, unless something comes up. But most likely, yes.
Okay, all right. So here's what we'll do. All right. So the first 10 minutes, 2 people can take a crack. 2, 5. Oh, I got balloons. Juliana. All right. All right. Okay. So 2 people can take a crack in the first 10 minutes, 5 minutes each. And you're going to code exactly what all these people did, which is to create a node class and then, for loops which populate that and so on and so forth. And if we have time, we'll go into deleting it, removing nodes and releasing it. So Eric, who else? Juliana, if you want to go again, that's fine. And I think it was Angelos. Okay, you guys should attend on Thursday. And then on Thursday we're going to do reflections, meaning you're going to think basically we're just going to hands off. You're going to look at you're going to be browsing on a different window in your browser, all of the posts that you've done, Reddit. Think back and make notes saying, all right, these are worthwhile things to create a final report, a reflection post that is gripping, all right, like a suspense novel. So you can, hey, I got another thing too, right? So yeah, okay, so you can do these really cool things. So we'll do that on Thursday, okay? And then that is, yeah, next quarter I'm teaching only online, 2A, 2B, 2C. And then in spring, it's only 2A, again, online. So I don't know when I'll be on campus. Well, I'm doing a couple of other things on campus, not teaching, but we'll see if they actually bring me to campus, physically. But I really totally enjoyed my time teaching you guys. Really lively and interesting, and a bunch that is excited about the things we're doing, all the projects we're doing in class. You take it to the next level. So it's been a great greatly fulfilling for me to teach you guys. Okay, so thank you all so much for being my students and being full of energy in class. Although you should be more energetic downstream in other classes, further down, especially when you go into college and all. You should in college, in university, there's a temptation to do too many things, right? So in university, there's so many things, so many clubs, so many activities and all these things. So you got to resist the temptation and say, all right, I'm actually here to learn new things, not to be increase my portfolio or resume. And it takes a lot of self-determination. So I'm not going to participate, I'm not going to do this and do that and stuff. I'm just going to learn, because that is the most valuable thing that you can get at the university. Okay, so you got to be totally into classes. Don't worry about anything at all. Things will just happen naturally, automatically. They'll fall into place in your life as long as you're doing the right things, learning all these cool things, because opportunities will just come to people who have talent. And so if you don't have talent, you don't get opportunities. But once you pick up the talent, this just come to you naturally. So otherwise you have to go on the road looking for things, right? So have things come to you rather than go looking for things. And then the best way to do that is just to pick up the skill and just ignore the pressures of the peer pressure in college, to just people emotional blackmail saying, hey, you got to save this puppy, or stuff like that, and be drawn off into tangents that is very likely to happen to many young college students I've seen, right? So you got to be careful. Best of luck, okay, in your final. I will see you in your reflection next class on Thursday. I'll talk to these other people who want to meet in person. Otherwise, we'll just meet on Zoom. And yeah, it has been a privilege to teach you guys, okay? Thank you all. And hopefully I'll see you on Thursday. And we'll get enough tips for your final reflections, right? And best of luck for your final. I'll say that again on Thursday. Yeah. Liam's working on something on the wall.
Yeah, sorry, I'm kind of busy. I have to go.
Yeah, don't worry. Okay. All right. I was just saying thank you all. Bye, and I will see you guys on Thursday. Okay. All right. See you.
Bye.
Email me about the jobs, the tutoring things, opportunities. I will get back to you.
Wait, add a quick
Yeah.
question.
Hey, Vikram, you got a question?
The final's next Thursday, right?
Next Thursday. Yeah.
All
Don't
right,
worry.
thank you. Thank you. Bye.
Cool. Bye.